and design and implementation of gray code to binary. The first we have to know that truth table from gray code to binary. That constructing the truth table I have shown separately in the prior to laboratory experiments, and that you can access by Sanjarka education by typing gray code to binary, and that has been shown separately how to construct that. And after that we have to see that we have to find a relationship of the B1 in terms of G1, G2, G3, G4, and B2 also similarly G1, G2, G3, G4, and B3 and B4 also similarly. Here from the truth table we have to I have to take the with the help of the K-map to find a relationship, and that I'm showing here. And you can see that after the plotting in the K-map from the truth table we are finding a relationship B1 equal to G1 and B2 equal to G1 XOR G2. In the similarly for B3 also you can see for the B3 from the truth table after substituting the values in the K-map, B3 equal to G1 XOR G2 XOR G3, and here simplification also shown here. And you can see here for B4 after substituting here we founded that relationship of the B4 with the G1, G2, G3 and G4, and it has been shown here, and the simplification also shown here. After that whatever we got after the simplification I have drawn in the with the XOR gate, and that in the lab we'll be implementing only with the basic gate. Therefore all the XOR gate are being replaced by the basic gate that I am showing here, and that for implementation we have to go to the lab and we'll implement it. Implementation of gray code to binary in digital IC trainer kits. We know that this is the truth table, and that truth table we have to realize in the digital IC trainer kits. And we know that this is the designing. After the designing, this is the designing of gray code to binary with the XOR gate, and we have to design with the only the basic gate. Therefore after that I am showing here this is the basic gates. We have replaced the XOR gate with the basic gates, and to implement it we should know that the pins 740 is the AND gate, this is the pin diagram, and 7432 is the 2 input OR gate, and then this is the same pin diagrams, and 7404 is NOT gate. This is the pin diagrams. We should know the pin diagrams, and then we are coming to the connections. And in the connections you can see I have connected the VCC and ground, only the VCC and ground, all these IC, and I'll show you that. I'll show you that this is the AND gate, this is the AND gate, this is also an AND gate, this is an OR gate, this is the OR gate, and this is the NOT gate. This is the 4, because we require 6 AND gate, therefore we require 2 ICs, and therefore this is the VCC I connected. Now we'll start the connections. Now first you see that G1 is equal to B1. Therefore I am connecting G1 here. This is the G1, and therefore directly I am connecting the B1 to the output, because G1 is equal to B1. Next you can see the for B2, creating a B2, you can see the output of the B2. You can look at the B2. Therefore first we have to start with the G1 only. Therefore G1 has to be complemented. Therefore I am connecting here G1. G1 is to be complemented. Complement is to be done by the NOT gate, connecting the input number 1, and the input number 2 output is the 2, and this is the complement of G1. Therefore I am coming to the AND gate now. AND gate, first AND gate I am connecting to the 1, and then you can look at the diagram as the G2. From G2 is coming, therefore I am creating a G2 here. You look at the G2, and connecting to, you can look at the diagram, is connecting the another input to the AND gate, therefore 2, and another input output of the AND gate number 1, you can say gate number output will go to the OR gate. The OR gate, the gate number 1, therefore it's a OR gate input to the pin number 1. It is connected to the pin number 1. Then coming to the second AND gate. Whichever the second AND gate I'll take, I told you that this is the gate number 1 we have connected, this is the gate number 2 we'll take, and this is the 3, and this is the 4. And then I am coming to the gate number AND gate 2. You can see directly it is coming from G1. It's coming from G1. Therefore, I am connecting to G1. It is coming to the 4 and 5 is the input. Therefore, I am connecting to 4. Therefore, now another input to the AND gate is coming from. You can look at that. It's coming from complement of G2. Therefore, I'm connecting to G2 now. I'm complemented by connecting to the 3 pin number 3 of the NOT gate, and the 4 is the complement. 4 is the complement. Next, it is coming to the AND gate and 5, input to the 5. And you can see that the 6 is the output of the second AND gate, and that is connected to the OR gate. OR gate, input to the OR gate, and then output of the OR gate. Output of the OR gate is 3, and that is the B2. Therefore, you can see it is I am connected to the output side. That is the B2. Continue the connection, so you can see the output of B2 is to be complemented first, then is given to the gate 3 of AND gate. Now, which gate 3 already I told. This is the inputs are 9 and 10, and output is 8. And gate 4, the inputs are 12 and 13, output is 11. And then come to the connections. Now you can see that first B2 is, this is the B2 already I have this, I place it here B2. B2 already I created here, and therefore I complement it first. Complement with the NOT gate, and then the 5 I am putting here, and the output is 6. Output is 6, and it is coming to the AND gate. AND gate already I told 9 or 10. Here already I told it is the numbering are changing in the right hand side. Therefore I am putting in the 9. Then you come to that. Then you come to the another input into the AND gate is coming from G3. Therefore G3 I am creating a G3 here. And then input side, and then it is coming to the then input to the 10, third AND gate input. Therefore 10, and output of the is 8 is going to the OR gate. OR gate. You can see this is a 4 and 5. One input is OR gate, and then you can come to the fourth AND gate. Fourth AND gate, that whatever you are using, the inputs are 12 and 13, and therefore you can see that again it is coming from B2. Therefore I am connecting to B2 here. Therefore directly it is coming to. I can connect it to 12. I can connect it to the 12 input to the fourth AND gate. Then you can look at that. Therefore G3, you can see G3 has to be complemented. Therefore G3 I am complementing here. The G3 I am connecting here G3, and it has to be complemented. Therefore fourth NOT gate I am using. The fourth NOT gate, one input is 9. Therefore input is 9 and output is 8. Therefore you can see that G3 has been complemented, and it has to be connected to the AND gate. The AND gate is already I told you that now I am connecting to 13, and output is 11. Output is 11. You have to connect it to OR gate. Therefore I am connecting to 11, and it will be connected to the OR gate inputs. Therefore I am here, you can see I am connecting to 5, and then you can see that output of the OR gate. The output of the OR gate is 6, and that is the, you can see that is the B3. Therefore I am creating here, therefore B3. You can look at that B3. You can see the B3 has to be complemented first. Therefore I am connecting to B3 here. You can look at that. I am connecting to B3, and I have to do the complement. You can use the 10 is the input, and 11 is the input, and 10 is the output. Therefore 11 I am connecting to 11, and 10 is the output. You can look at the 10 is the output here. I am connecting to that. The B3 has been complemented, and then you can see is the AND gate, input to the AND gate. AND gate, this is the fifth AND gate. AND gate is to be the second IC. Therefore I am connecting to 1 here. And then you can see from G4, that is I am creating here G4. You look at that, you can creating here G4, and directly coming to the another input to the AND gate. Therefore 2 is the another input to the AND gate, and then you can see that 3 is the output of the AND gate, and then it is going to the third OR gate. Therefore third OR gate which you use, the inputs are 9 and 10, therefore I am connecting to 9, connecting to 9 of the OR gate, and then you can see the last AND gate. Therefore you can see this is the B3, directly it is coming to the last AND gate. Therefore last AND gate is the input are the 4 and 5, therefore I am connecting to 4, and then you can see the G4 has to be complemented. Therefore G4, I am connecting to G4 here, and you can see the NOT gate, the input is the 13 and the output is the 12. Therefore you can see is the 13 and output is the 12. Output is the 12. I am connecting the 12. You can see that is connecting to the 5, and output is the 6. It is coming to the OR gate. OR gate is 10. The third OR gate, it is connecting 10. The output of the OR gate is 8. Then I am connecting this is the B4, and that is all about the connection. Then we will see the output. Go for a verification of the truth table in the digital IC trainer kits. Now you look at that when all are 0, 0, 0, G1 to G4 and B1 to B4 all are 0. Therefore I make it to G4 equal to 1, and in this case according to the truth table B4 also will be 1. Therefore I am making G4 equal to 1. Therefore you can see here that B4 is becoming 1. Therefore in the third row you can see therefore G3 is equal to 1. In this case B3 and B4 both will be 1. Therefore I make it off. G4 I make it off. G3 if I make it on, therefore B3 and B4 both will be 1. Therefore you can see B3 and B4 becoming 1. Then you come to the then you switch off. Then you come to the fourth. You can come to the fourth row and 0, 0, 1, 1. Therefore if I make G3 and G4 both are 1, therefore only B3 will go. Therefore G3, therefore if I make it these two on, therefore you can see therefore G3 and G4 is 1, and therefore only here you can see B3 is equal to 1 according to the truth table. Therefore in this way we can go for verifying all the 16 variations, and then our verification will be over. And that is all about the realization of the gray code to binary code conversion in a digital IC trainer kit.